a new letter. This is the graph of j of x. Sketch the image graph after a translation of 4 units to the left and 5 units down. So I'm going to take each of these points. I'm going to go 1, 2, 3, 4. 1, 2, 3, 4, 5, and draw that point. 1, 2, 3, 4. 1, 2, 3, 4, 5. And this maximum point here. 1, 2, 3, 4. 1, 2. So I found those sort of 3 key points. I'll highlight them on the red graph as well. And I just moved it 4 to the left and 5 down. This is not crazy. Draw the same shape going through. The textbook does not have arrowheads on the end of the graph, but anytime their graph hits the edge of their graph paper, we have to assume it continues going on forever. So I'll add arrowheads on there. And I have now graphed the blue one. So sketch the image after translation of 4 units left and 5 units down. Write the equation in terms of j of x. So in terms of j means that we need to show the 4 units to the left and the 5 units down. Anything left and right is inside the function. So if I have function notation, inside the function would be here, inside of j. Moving 4 units to the left would be the opposite, x plus 4. Then moving 5 units down would have a minus 5 at the end. State the domain and range of each function, including the original, I suppose. So I'm going to do the domain and range of the original in red. Domain are your x values. Again, I find it's a good strategy to say, start with, is there a smallest x value? So here, because of this arrowhead means it's going up forever and also going forever to the left. So technically, we would have no smallest value because it's going forever to the left. This arrowhead on this side means that it's going up forever. It also means that it's going forever to the right. So we also have no biggest x value. We have every single x value. If there's no smallest one and no biggest one, we have every single x value. We can write that in set notation like this, or in interval notation from negative infinity to infinity. For the red graph, for the range, is there a smallest y value? Yes, coming from the bottom, you'd get to 0. 0 would be your smallest y value. Is there a biggest y value? No, it goes up forever. So your y values are always bigger than 0. In set notation, you would write that like this. Y is greater than 0. In interval notation, start with your smallest value of 0 and go up forever to infinity. We always use round brackets with infinity. Yes?
Isn't it minus 5?
That's for the blue one. Notice I'm writing here in red to go with the red graph. Yes. So now when we get to the blue one is still everything for the domain, and the range is y is bigger than or equal to negative 5. So for the blue one, I just did set notation. When a question asks for domain and range, you get to choose which notation you'd like to use. But we need to know both because sometimes mental math questions have both. So now circle 8, 9, and 10.